The solar system is pretty huge, containing 8 planets, dwarf planets, moons, asteroids, and comets. So how did all this stuff come to be? Let's look at the birth of our solar system. Over 4.6 billion years ago, there was no sun, no Earth, just a cold cloud of gas and dust drifting in space. It's hard for us to imagine now because we're so used to seeing the sun shining brightly in the sky. But back then, the closest thing the Earth had to a star was a dim coal ember. But that'll change because something is going to happen that will make all the difference. Maybe a nearby star explodes as a supernova, sending shockwaves rippling out into space. Particles collide, stick together, and slowly form planetesimals. The larger they get, the more gravity affects them. They attract more dust and grow even bigger. The smallest 4 inner planets, Mercury, Venus, Earth, and Mars, are terrestrial planets. They're relatively small and close to the Sun, at about 222 million kilometers from the Sun. Mars is a terrestrial planet with a thin atmosphere. It has a rusty red color due to iron oxide or rust covering its surface. Mars has 2 moons named Phobos and Deimos. No rings, no moons. That's unusual for a gas giant. The outer 4 planets, Jupiter, Saturn, Neptune, and Uranus, are gas giants. They're massive and far from the Sun. Its mass is 2.5 times larger than all the other planets combined. Other solar systems have multiple suns. Some planets have multiple moons, and some systems have multiple disks of planets. Our solar system is a bit unique. When a large body collides with another, energy is released as light and heat. If it's massive enough, it can strip away entire layers of a planet's atmosphere. For example, scientists think a Mars-sized planet crashed into early Earth, giving our world its present mass and forming our moon. The debris kicked up by the collision would have remained in orbit and eventually cooled, forming the moon. Scientists also think collisions played a part in forming the asteroid belt and the Kuiper belt, the region of icy bodies beyond Neptune. Its iconic Great Red Spot is actually a massive storm rising above its surface. This is a theoretical sphere of icy objects surrounding the solar system, extending as far as 100,000 astronomical units from the Sun. 1 astronomical unit being the average distance between the Earth and the Sun. They were created by stellar winds from nearby stars, carving out pockets of space that are easier for spacecraft like Voyager 1 to travel through. It's thought that long ago, when the solar system was still forming, leftover material from the disk of gas and dust condensed into the bodies of the Oort cloud. As long as there have been humans on Earth, we've looked up at the stars and wondered about our place in the universe. Ancient cultures developed their own explanations for how the cosmos began. While we now know that these myths aren't scientifically accurate, they reveal a great deal about the people who created them. Jupiter has faint rings and at least 79 known moons, including Europa, which scientists think could harbor life beneath its icy surface. On average, particles closer to the Sun are lighter and smaller. Like Jupiter, Saturn is a gas giant, but it's not nearly as massive. How do you feel about the nebular hypothesis? What surprised you the most? Neptune has 14 known moons, including Triton, which orbits the planet backwards. Could Triton have been captured by Neptune's gravity? Uranus rotates on its side, perhaps after being hit by a massive object in the past. Scientists think this sideways orientation is the reason Uranus has rings. We don't know, but we do know that Neptune's discovery in 1846 was the first planet to be discovered by mathematical calculation alone. Astronomers predicted where it should be, and then they found it. Saturn has plenty of rings, intermediate in complexity between the simpler rings found around Jupiter and Neptune, and the more extensive set around Jupiter. Scientists think the majority of Saturn's many moons formed from material that got caught up in the rings. The farther away from the Sun, the heavier and larger the particles become. A strong stellar wind from an already existing star or a shock wave from a supernova passing by could have also affected the cloud. Further out, where things are much colder, heavier elements like oxygen, carbon, and iron can exist as gases. These materials combine to form ices, and along with lighter elements form water, methane, and ammonia. Since these compounds are less dense than rock and metal, they form larger worlds. Worlds made mostly of rock and metal tend to be smaller and denser, while worlds made of ice and gas tend to be larger and less dense. Hydrogen atoms smash into one another, forming helium and releasing even more energy, which causes more hydrogen to fuse, and the reaction becomes self-sustaining. And right there in the middle of the spinning disk of dust and gas, the sun is born. The exact mechanism isn't important here. What matters is that something jostles the cloud. Gravity takes over. The cloud collapses inward and starts spinning faster and faster. At its center, pressure builds up until the temperature reaches about 10 million degrees Celsius, hot enough to ignite nuclear fusion. Around it, most of the leftover gas and dust flatten into a spinning disk. Some material never gets incorporated to the new star and remains as a collection of smaller bodies like asteroids and comets. Eventually, all the leftover material condenses into smaller bodies that orbit the sun. As always, our story begins with a humble grain of dust. Closer to the sun, the worlds that form are primarily made of rock and metal because only those elements are heavy enough to stay together in the high heat. After 10 million years or so, the planets are fully formed. Let's take a closer look at some of our neighbors. First, let's head over to Mars. Now, let's fly by Jupiter, the largest planet in the solar system. Next, we arrive at Saturn, known for its spectacular rings. We've almost reached Neptune. This ice giant has rings too, but unlike Saturn's rings, they're intermediate in complexity. Finally, we've arrived at Uranus, another ice giant with 15 known moons. So that's what the neighborhood looks like. But the story doesn't end there. For starters, scientists think that asteroid impacts played a major role in shaping the solar system as we know it today. Speaking of belts, let's talk about the Oort cloud. But wait, there's more. Our solar system also has several donut-shaped structures known as the local bubble and the greater structure known as the heliosphere. And that's how our solar system came to be. Join us next time as we explore ancient creation stories and learn how early humans conceptualized the universe. There are more than 100 billion Earth-like planets out there in our galaxy. And if life does exist elsewhere in the universe, it is a pretty good bet that those aliens have looked up at our night sky, just like we have, and wondered if there's anyone up there with them. So let us take a trip back in time to see how ancient humans turned the planets into gods. But for most of human history, our explanations for what we saw up there weren't very scientific. They were stories. The sky was thought to be a living being who gave birth to all the gods and everything else. In some stories, he was born from the primordial waters of Nun. To them, Ammon was all-powerful, and he ruled over the other gods, just like a pharaoh rules over his people. Then she gives birth to 4 children who restore order to the world. Across the Mediterranean, the Greeks told stories of Helios, who drove his golden chariot across the heavens each day. His brother, the god Apollo, liked to race around the earth in his chariot too. And the Greeks believed that when Apollo pulled his chariot across the sky, he brought music with him. That's where we got our word for Monday, which is named after him. And Apollo wasn't the only one who associated the planets with music. The Greeks would probably have recognized him as Helios, since both gods were associated with the sun. But Hindus saw Vishnu in everything. For example, some identified Vishnu with the planet Jupiter because of its reddish color, which reminded them of the god's skin. Others connected Vishnu to the North Star because it stayed still in the sky, just like the god feet. And yet others believed that the Milky Way was made of Vishnu's footprints. Some ancient Chinese astronomers believed that Mars predicted eclipses, and they weren't wrong. One Greek philosopher named Anaxagoras believed that the moon didn't shine on its own, but it reflected the sunlight. He was also one of the first to propose that the Earth was a sphere and that it revolved around the sun. Of course, he wasn't the only one who questioned traditional beliefs about the sky. After all, the red planet does sometimes pass between the Earth and the moon. But whether they believed the planets were gods or just rocks floating through space, one thing is clear. Ancient people everywhere were fascinated by the sky. We may not look up and see gods and monsters anymore, but we still dream of visiting other worlds and meeting new life. Maybe someday we will find planets just like the ancient Egyptians imagined, worlds where the sun rises and sets every day and where the gods sail across the sky. But maybe there'll be places we haven't even dreamed of yet. Thanks for watching this Sea Show video. But they took it a step farther and claimed that Mars caused the solar and lunar eclipses. The Romans named Mars after the god of war because they heard the planet make a sound like clashing arms. According to Hindu mythology, Brahma created the universe and everything in it, but he can't control it. Instead, Vishnu keeps the universe running smoothly. And when it comes time for Vishnu to rest, Shiva steps in and destroys the universe so that Brahma can start over again. So, Hindus use the cycle of creation, preservation, and destruction to explain the phases of the moon and the movements of the planets. Like Re, Helios was immortal, but he was also cursed never to touch land again. Norse mythology tells the story of two brothers, the god Heimdall and the giant Loki. Each morning they woke up before sunrise and raced across the sky, driving their chariots. Heimdall drove the sun, and Loki drove the moon. The ancient Mesopotamians associated the 5 planets they could see with their gods too. So Heimdall grabbed his spear and chased after Loki, and from then on, the two brothers spent their days running from each other across the sky. This myth explained why the moon seemed to follow the sun in the sky, and it also explained why sometimes the moon didn't rise until after the sun had already set. In Norse mythology, that was because Loki had taken an extra long break to quench his thirst with mead. And they linked the waxing and waning of the moon to the fertility of the goddess Ishtar. In fact, Ishtar's association with the moon was so strong that the Babylonians called the crescent moon the horns of Ishtar. That's because one time he gave a monster named Typhoon a ride in his chariot. And when Typhoon tried to strike him down and steal the chariot, Helios jumped into the sea and was rescued by the Titan, Oceanus, who took him to live among the gods on Olympus. In another version, it's Re's son, Horus, who comes to his father's aid. He slays the forces of chaos and brings back the light. Either way, this myth explains why the Egyptians kept their dead pharaohs buried deep in the ground. If the king died when the sun set, then his body would be entombed with precious goods so he could sustain himself until the next sunrise. Over time, the two cults merged and their gods became one. And so the sun god Ra became Amun-Ra, the supreme ruler of the universe. In others, he sprang fully formed from the head of the god Atum. You see, the Egyptians had no concept of a greenhouse effect. So to them, every sunrise was a brand new creation, and every sunset was the end of the world. In India, the god Brahma was said to sit on a lotus flower in the middle of a cosmic ocean. From there, he observed the world and created everything, but he didn't do it alone. Brahma worked with the other members of the Hindu trinity, the preserver, Vishnu, and the destroyer, Shiva. That meant that Re was always in danger of being destroyed when he battled the forces of chaos every evening. And the Egyptians believed that sometimes Ra actually did die. During these times, the world descended into darkness and disorder, and only Re's consort could save him. And in yet another tradition, Ra was one of many deities that shared the world equally, along with his wife, the earth goddess. But by the late New Kingdom, Ra had become the supreme ruler of the cosmos, and the other gods had become his servants. Every morning, the sun god Ra sailed across the sky in his boat, bringing light and warmth to the world below. When he reached the horizon, he would battle the forces of chaos represented by the goddess Nut and her children. Together, they were an eternal family, doomed to spend eternity locked in an endless struggle. And while these myths and legends might seem silly or even childish today, they played a huge role in shaping how we think about the cosmos and how we explore it. The first known story about the sun comes from ancient Egypt, where the pharaohs were considered divine. Like many Egyptian gods, Ra wasn't exactly unique. He had many forms and many names, but not everyone agreed. Another cult in Egypt worshipped Amun, the king of the gods. But in Egypt, worshipping the sun wasn't always a walk in the park. It could be dangerous. In one version of the myth, Nut takes the form of a cow and shelters Ra under her body. Ra wasn't the only deity who sailed the skies. But Helios wasn't the only Greek deity who had a thing for chariots. And all this naming wasn't limited to the planets. But not all ancient cultures saw the gods traveling across the sky, and Vishnu, unlike Brahma, was always on the move. But these stories weren't just about identifying the planets. They were about understanding how the universe worked. Meanwhile, in Scandinavia, the gods weren't hanging out on Mount Olympus or sailing across the sky. They were being chased through the heavens by wolves. Now, normally the brothers got along, but one day Loki cut in front of Heimdall during the race. Of course, the Norse weren't the only ones who had wild theories about the planets, but not all ancient astronomers were so sure about astrology. The Mayan astronomer intervened to say that the moon didn't reflect light at all. It just looked that way because it was close to the sun. And while today we know a lot more about the planets, we're still driven by the same curiosity. What is the story of the solar system? Well, we know what it is scientifically. We know it's a collection of planets, asteroids, comets, dwarf planets, and other space rocks orbiting the sun. Back then, people didn't just watch the sky, they studied it. They saw patterns in the stars, the planets, and the moon. They saw that the moon changed shape over the course of a year, and they realized that these changes were linked to the amount of sunlight that hit the moon's surface. Across the world, another civilization was looking up at the sky and wondering about its mysteries. The Maya built impressive temples and pyramids that were aligned with the stars and used these structures to track the movement of the celestial bodies. Chinese astronomers kept detailed records of their observations of comets, supernovas, and other celestial events. They were particularly interested in comets and saw them as omens of important events on Earth. Their observations and discoveries paved the way for the scientific revolution that would come centuries later. They showed us that the sky was not just a mythological realm, but a subject to scientific investigation. And they showed us that the Earth was not just the center of the universe, but a planet revolving around the sun. They were the first to unravel the mysteries of the cosmos and show us that the universe was full of wonders waiting to be discovered. Their legacy lives on in the scientific method and the spirit of inquiry that drives us to explore the unknown. And as we continue to explore the solar system and beyond, we can be inspired by the curiosity and determination of the ancient astronomers who first gazed up at the stars and wondered about the nature of the universe. So the next time you look up at the night sky, remember the ancient people who first looked up and wondered what was up there. Remember the Babylonians, the Greeks, the Maya and the Chinese, and all the other ancient cultures that made important contributions to our understanding of the solar system. Their discoveries were the first steps in our journey to understand our place in the universe, and their legacy continues to inspire us today. The Chinese also developed a sophisticated instrument for measuring the brightness of stars and used this instrument to track the movements of the planets. One of the most famous Chinese astronomers was Shi Shangqi, who lived during the Han Dynasty. Shi Shangqi was responsible for compiling the first official Chinese star catalog, which included more than 1,000 stars. He also developed a new instrument for measuring the positions of stars, which allowed him to make more accurate predictions of astronomical events. They were particularly fascinated by the planet Venus, which they identified as a morning and evening star, and followed its path across the sky. The Maya kept meticulous records of astronomical phenomena such as comets and eclipses and used these observations to develop a highly accurate calendar system. They also believed that the sun was a god and celebrated solstices and equinoxes with great festivals. It was the ancient Greeks who lived on the mainland and islands of Greece, including Crete. Here, too, people were observing the sky and trying to make sense of what they saw. Well, first, we can see that the study of the solar system goes back thousands of years. People have been observing and recording the movements of the celestial bodies since the dawn of human civilization. Second, we can see that ancient people were not just passive observers of the sky. They were active investigators who tried to understand the patterns and cycles they saw. They used math and astronomy to predict eclipses, seasons, and other astronomical events. Third, we can see that the ancient people's understanding of the solar system was limited by the technology and knowledge available to them. For example, they often believed that the Earth was the center of the universe and that the sun and other planets revolved around it. However, they made some remarkable discoveries despite these limitations. For example, the Maya accurately predicted the return of Halley, S. Comet and Aristarchus of Samos proposed a heliocentric model of the solar system centuries before Copernicus. Finally, we can see that the ancient people's understanding of the solar system was closely tied to their religious beliefs and mythology. For example, the Babylonians believed that the sun god Shamash rode a chariot across the sky, and the Maya believed that the sun was a god. However, their observations of the sky were still a key part of their astronomical discoveries. The Greeks were known for their love of knowledge and their desire to understand the world around them. And it was this curiosity that led them to make some groundbreaking discoveries about the solar system. Some of the most famous Greek astronomers included Pythagoras, who lived from around 570 to 495 BC. He was a philosopher and mathematician who is best known for his theorem about right triangles. But he was also interested in astronomy, and he made some important contributions to the field. Pythagoras and his followers believed that the Earth was a sphere and that it was surrounded by a crystalline sphere that contained the stars. They also believed that the sun and the moon were also spheres and that they moved in circles around the Earth. While these ideas were not entirely accurate, they were still significant because they represented a departure from the traditional Greek belief that the Earth was flat. Another famous Greek astronomer was Aristarchus of Samos, who lived from around 310 to 230 BC. Aristarchus was a mathematician and astronomer who was best known for his heliocentric model of the solar system. That's right. He proposed that the sun, not the Earth, was the center of the universe. Now, Aristarchus reached this conclusion by measuring the relative sizes of the sun and the moon, and by observing the phases of Venus. He also suggested that the other planets revolved around the sun in circular orbits. Unfortunately, Aristarchus's ideas were not widely accepted during his lifetime. Most astronomers continued to believe that the Earth was the center of the universe. But his work laid the groundwork for the heliocentric theory that would be proposed by Nicolaus Copernicus centuries later. They also noticed that the moon cycle was exactly 27 days long, and they used this knowledge to create calendars and predict eclipses. They also made important strides in understanding the planets, and they were among the first to recognize that some planets moved differently than others. They saw that Mars, Mercury, Jupiter, and Venus seemed to wander or retrograded through the sky, while Saturn moved more slowly and never strayed too far from the path of the sun. They even developed a sophisticated system for tracking the planets and predicting their movements, which was based on their cyclical behavior. These discoveries were a huge step forward for the Babylonians and laid the foundation for many of the astronomical discoveries that would come later. And eventually they learned how to use those patterns to help them predict things like when the next eclipse would happen, or when it would be time to plant crops. So let us take a journey through time and space to explore how our ancestors unlocked the secrets of the cosmos. But how do we know its story? How do we go from this to this? Well, today we read going back to the dawn of human civilization to find out how ancient people came to understand their place in the cosmos and how they discovered the scientific truths that allowed them to do so. This is the story of our solar system. This is a story that takes us back thousands of years ago when humanity was still young. Let's start our tale in ancient Mesopotamia between the rivers Tigris and Euphrates. There, in the land between these rivers, the first civilization had emerged. It was here that the first myths about the gods and the creation of the world began to form. For example, the Babylonians told tales of how the sun god Shamash rode his chariot across the sky each day, bringing light and warmth to the world below. Now, while these stories are full of symbolism and meaning, they also contain kernels of truth that the Babylonians had observed about the natural world. They had noticed that the sun rose in the east and set in the west, that it moved across the sky in a predictable path. But they didn't just accept what they saw, they wanted to understand it. And so they began to keep careful records of the movements of the celestial bodies. They used math and astronomy to predict when eclipses would occur, when the seasons would change, and even when certain stars would appear in the sky. To do this, they carved their observations onto clay tablets, creating a record of their findings for future generations. And it was through these records that the Babylonians made some truly remarkable discoveries. Now, one of the most important things that the Babylonians learned was that the phases of the moon were related to the cycle of day and night. But the Babylonians weren't the only ones making discoveries. Next, we traveled to the Yucatan Peninsula in ancient Mexico, where the Maya civilization had developed a complex society with a sophisticated understanding of mathematics and astronomy. Finally, let's visit ancient China, where a continuous tradition of astronomy developed over many centuries. So, what can we learn from all these ancient cultures? The ancient people's understanding of the solar system was a crucial step in our quest to understand our place in the universe. Hey, would you look at that? It's another origin story. You know how they say you never forget your first love. See, back then we were working with some pretty limited data. Most of what we knew came from stories of gods or old myths. And when it came to the science, well, we had some ideas, but nothing concrete. This explained how every object in the universe attracts every other object with a force that depends on their masses and the distance between them. Basically, the more massive an object, the stronger its gravitational pull. And the closer objects are to each other, the stronger the gravitational attraction between them. When applied to the solar system, Newton's law showed that the sun's strong gravity keeps all the planets in orbit around it. After patiently photographing small sections of the sky, night after night, he finally captured Pluto as it moved against the background stars, giving us our 9th planet. The discovery of Pluto sent shockwaves throughout the scientific community and captivated the public imagination. For the first time in almost 300 years, we had discovered a new planet in our solar system. But not only that, it also explained why the moon orbits Earth and why. Earth and the other planets orbit the sun. In 2003, a team of astronomers announced the discovery of Sedna, a dwarf planet located at the edge of the solar system. We've only scratched the surface of exploring our cosmic backyard, and there's so much more to discover. Take the origin of the solar system, for example. We've got a pretty good idea of how it all started based on the nebular hypothesis. This model suggests that our solar system formed from a giant cloud of gas and dust that collapsed in on itself, eventually forming the sun and the planets. But there are still a lot of unanswered questions here. Like, how did that initial cloud form in the first place? As Carl Sagan once said, we are a way for the cosmos to know itself. Our solar system is our cosmic home, and it's up to us to explore it, understand it, and protect it. So, let's continue to push the boundaries of what's possible, explore the unknown, and uncover the mysteries that lie within our grasp. Who knows what incredible discoveries await us in the years to come, or what caused it to collapse? Even though we've come a long way from the days of ancient myths and legends, we are still driven by the same curiosity and wonder that has inspired humanity for millennia. The desire to understand our place in the universe and explore the vast expanse of space beyond our world is as strong as ever. And who knows what incredible discoveries await us in the years to come? And shortly after, they found Eris, another dwarf planet in the Kuiper Belt. And then in 2012, the European Space Agency's Rosetta spacecraft reached Comet 67P Churyumov-Gerasimenko and landed a probe on its surface. We know that it's full of rocky leftovers from the early days of the solar system, but what exactly is it doing there? Between Mars and Jupiter, there are several regions where there are significantly fewer asteroids than in other parts of the belt. What's going on there? Are there other factors at play that we're not aware of? And why hasn't it turned into a planet? There are also the strange properties of Uranus and Neptune to consider. We've only begun to scratch the surface of what's out there, and the more we learn, the more we realize just how much we don't know. But that's part of what makes exploring space so exciting. Every new discovery brings us one step closer to unraveling the secrets of the universe and helps us better understand our place in it. Both planets have unusual axial tilts, which means that they rotate on their axes at a steep angle. This suggests that something weird must have happened to them in the past, like a collision with another large body. But what could that have been? This was the first ever spacecraft to land on a comet, providing invaluable insights into its composition and structure. At long last, we finally had a plausible explanation for how the solar system functions. These discoveries demonstrated that our understanding of the solar system was far from complete, and that there was still so much more to explore. Well, I feel the same way about the solar system. In 2019, NASA's Parker Solar Probe touched the sun for the first time, becoming the first spacecraft to ever do so. Who knows what the future may hold? Maybe we'll discover new worlds beyond our wildest imaginations or uncover the secrets of the sun and its corona. The possibilities are truly endless. This groundbreaking mission aimed to study the sun's outer atmosphere, known as the corona, and its influence on the solar wind and space weather. Meanwhile, the Voyager probes, launched in 1977, continued to send back valuable data from the farthest reaches of the solar system. Voyager 1 is now just a few kilometers from the interstellar boundary, and both spacecraft are expected to continue operating until at least 2025. After all, Newton's law of universal gravitation predicted that any massive object could be orbited by smaller objects. And if the Earth could have moons, then other planets could too. I mean, it was the first one I ever knew. And just 7 years later, Giovanni Cassini found 4 more moons of Saturn. But then again, that wasn't the end of the story either. Just a few decades later, in 1846, Italian astronomer Giovanni Battista Amici built a telescope capable of splitting double stars and seeing fine details on the moon's surface. His work laid the foundation for modern optical design and helped astronomers see things in space like never before. He also found 4 more moons of Jupiter in 1675, making him the first person ever to discover moons outside of our own solar system. Then in 1781, William Herschel discovered Uranus, the first new planet since the days of the ancient Greeks. And just 2 years later, he discovered the asteroid belt between Mars and Jupiter. These discoveries were game changers. They proved that our solar system was a lot more complex than we had imagined and inspired a whole new generation of astronomers. But then again, I don't really remember much about my childhood. For example, ancient Greek philosophers had 2 competing theories on where the stars went during the day. Some said the sky rotated like a sphere, carrying the stars along with it. Let us go back to the 1600s when scientists finally began to unravel the secrets of the solar system. That's when German astronomer Johannes Kepler published his 3 laws of planetary motion. They showed that planets orbit the sun in ellipses rather than circles, which made sense given that a circle is just an ellipse with 2 focal points coinciding. The next law stated that planets sweep out equal areas in equal amounts of time as they orbit the sun. So planets move faster when they're closer to the sun, and slower when they're farther away. And finally, the 3rd law revealed a precise mathematical relationship between the orbital period of a planet and its average distance from the sun. Kepler's laws were revolutionary because they dealt a death blow to the long-standing geocentric theory. If Earth were truly the center of the universe, as everyone had been led to believe, the planets would move very differently. Others said the Earth was fixed and the stars appeared to move around it because they were embedded in crystal spheres. Unfortunately, this last idea prevailed for over 1,000 years. Not because it was correct, mind you, but because it aligned perfectly with the prevailing geocentric model of the universe. That's right, for most of human history, we thought the Earth was the center of everything. But even though it took a while for the truth to emerge, once we started uncovering it, everything fell into place. And the truth didn't stop there. A few decades later, Sir Isaac Newton published his law of universal gravitation. So let's take a moment to appreciate how far we've come. But then again, maybe we should have seen this coming. In 1665, Dutch astronomer Christian Huygens discovered Titan, the largest of Saturn's moons. And let's not forget that this was all happening without spaceships or satellites. All these discoveries were made with simple, ground-based telescopes. Then in 1930, Clyde Tombaugh used a telescope to scour the skies for planets beyond Neptune. Of course, not everyone was convinced that Pluto was a true planet. But perhaps the most exciting discovery came in 2016 when the New Horizons probe flew by Pluto, sending back stunning images of the dwarf planet's diverse terrain, including towering ice mountains, vast plains, and craters left over from ancient impacts. But then again, the story doesn't end there. These incredible feats of exploration have not only advanced our understanding of the solar system, but have also pushed the boundaries of what we thought was possible. And yet, despite all these advances, there is still so much that we don't know. We may have uncovered many of the mysteries surrounding our solar system, but the truth is that the more we learn, the more questions we seem to find. Then there's the issue of the asteroid belt. And let's not forget about those mysterious gaps in the asteroid belt. But the truth is that these are just a few examples of the many mysteries that still surround our solar system. From the smallest asteroid to the largest planet, each object in our solar system has a unique story to tell, and it's up to us to listen. Thanks for watching.